All right, now that we know that rational functions usually have asymptotes, and we know where the vertical asymptotes are going to occur and how to figure out the behavior near them, we're going to take a look at an example rational function, and we're going to figure out what the x and y intercepts are, as well as where the vertical asymptotes are and what the behavior is near the vertical asymptotes. We still don't quite have enough information to sketch the graph because we haven't discussed end behavior yet, but I want to focus on all of these other aspects and get comfortable with them before we look at end behavior. So first, to find the vertical asymptotes, we know that those occur when the denominator is equal to 0, and so it's actually easier for us to look at this with the denominator factored. If we use the unfoiling method to factor x squared plus 2x minus 3, that should give us x plus 3 times x minus 1. Now, we know that the denominator is equal to 0 when either of these factors is equal to 0, and that's going to be when x is negative 3 and when x is positive 1. So the vertical asymptotes are going to be at x equals negative 3 and x equals positive 1. Now I'm going to give us an xy plane so we can graph this and see what this gives us. So here we have our xy plane. We know we've got a vertical asymptote at negative 3. So I'm going to draw a dashed line to represent that. And then we also have one at positive 1, so we have a dashed line that we need to represent that. So we know that these are going to be our vertical asymptotes, but we don't know if the graph is going to be going up on each of these sides or down, or if it's going to be going up and then down, and then down, and then up, or up, and then down, and then up, and then down. There's all sorts of possibilities. So we're eventually going to need to look and see what's happening as x gets closer to 1 from the left and also from the right, and the same with negative 3. And the way that we can do this is with a little table of values. So let's look at the asymptote x equals 1. Now we need to pick x values that are getting closer and closer to 1, and we want to do this on the left side and the right side. So on the left side, those values, we could pick 0.9, 0.99, and 0.999. And then on the right side, we can pick 1.1, 1.01, and 1.001. Now, I'm not going to write out the calculations by hand. I actually am using a scientific calculator, which I would recommend you do as well. When you do these calculations, you should get something approximately equal to negative 8, negative 75, and negative 750 for the values to the left-hand side. And then for the right-hand side, you should get positive 8 approximately, 75, and 750. These are all approximations. And so what we can see here is on the left-hand side, as x gets closer and closer to 1 on the left, our values are getting bigger in the negative direction, and so we're going to be going downward. And the way that we can write this algebraically is that y approaches negative infinity as x approaches 1, and I'm going to put a little minus above that because we're approaching 1 from the left, from the negative side. Now, on the other hand, when we're approaching 1 from the positive side, 1.1, 1.01, 1.001, as we're getting closer and closer to 1 from the right, The y values are getting bigger and bigger and bigger, going towards positive infinity, so we can say that y approaches positive infinity as x approaches 1 from the right. So that tells us a little bit about what the graph is going to look like. We're going to use this in just a couple minutes, but I want to look at the other asymptote, the other vertical asymptote, that corresponds to x equals -3. So again, we're going to need to make two tables of values that correspond to x getting closer and closer to -3. On the left, that's going to be -3.1, -3.01, -3.001. And then on the right, that's going to be -2.9, -2.99, and -2.999. Now, when we make our table of values, we get -3, -25, and -250. Again, these are just approximations. And so we can see here that y is approaching -infinity as x approaches -3 from the left. And for the other one, we get approximately 2, 25, and 250. So here y is approaching positive infinity as x approaches -3 from the right-hand side. Now, we will eventually use this to figure out what the graph looks like, but first we need some starting points. We don't have a single point on this graph yet, and so what we're going to do is we're going to look at intercepts. Now, for the x-intercepts, remember the x-intercept happens when the function value is equal to 0. And the function value is going to be 0 when the numerator equals 0. Because 0 divided by anything other than 0 is 0. So what we need to do is we need to find when the numerator equals 0. It's interesting. We get vertical asymptotes when the denominator equals 0, and we get an x-intercept when the numerator equals 0. Well, the numerator is going to equal 0 when x is -2. So that ends up giving us our x-intercept, x equals -2. That is a starting point. And then also, we can get the y-intercept fairly easily because we know this happens when x equals 0. And when we plug in x equals 0 to the function, this term, and this term all become 0. And what we're left with is 2 over -3, or -2/3. So our y-intercept, this is when x equals 0. The y-intercept is -2/3. That's going to be right here. So we've got a couple of points that we can start with. Now let's take a look at what's happening between the asymptotes. We've got 2 points here. Let's look at what happens as we approach this asymptote from the left. Well, as x approaches 1 from the left, we know that y is approaching -infinity. So that tells us that we're going to be going downward towards -infinity on the left. Then we know we're going to connect the dots. And then let's look at what happens as we approach this asymptote from the right-hand side. As we approach -3 from the positive side, y is approaching positive infinity. So we know that it's going to be going up as it approaches that asymptote. Good. Now, let's look at what happens on the right-hand side. Now, while we're looking close to this asymptote, as x approaches 1 from the right, we know that y approaches positive infinity. So we know that we're going to be going up, 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 up here. But we don't yet know what's going to happen to the right. And this is something that we're not going to learn until the next lesson. I'm going to tell you right now, just so that we can complete the graph, that we will have a horizontal asymptote for the x-axis. So it's going to get closer and closer to that. But that's not something that we're going to learn how to do for ourselves until the next lesson. Now let's also look at what's happening on the left side of this asymptote. As x approaches -3 from the left, y is approaching -infinity, so that tells us that we're going to be going down as we approach this. And again, we do not yet know how to figure out the end behavior on the left, but I'm just going to tell you that we are going to be asymptotically approaching the x-axis, but on the left side. So this is a sketch of the graph of f of x equals x plus 2 over x squared plus 2x minus 3. At this point, we're capable of finding the x and y intercepts. We're capable of figuring out where the vertical asymptotes will be, and with a little bit of work and some tables of values, we can figure out if the graph is going to be going up or down on each side of those vertical asymptotes. For the homework today, you're going to be looking at where these asymptotes are and where the intercepts are. And then when we get to the next lesson, we're going to be able to figure out the end behavior and figure out the horizontal asymptotes. We're going to have situations where there are slant or diagonal asymptotes and other end behavior, and then we'll finally put this together to where we're sketching entire graphs of rational functions. Now, each individual rational function takes quite a lot of work to graph because we've got these tables of values that we have to do with lots of decimal numbers. So we're not going to do too many examples, but we want to get a good idea of what graphs of rational functions look like so that we can understand the behavior of different things that are modeled off of rational functions in the real world.